Welcome again to QSO 520, and today we're going to focus on multiple objective linear programming models, and we can say MOLP models. And remember, most of linear programming models or even integer linear programming models consider just one objective function, and that is either maximizing profit or maximizing benefit, or minimizing losses, or getting a particular value. But each problem was focusing on just one objective function. Now we are looking at the multiple objective function. For instance, let's say a company is producing some goods, and at the same time the company releases some pollution. The company may want to maximize profit, but at the same time it would like to minimize pollution. However, we know that the more profit the company makes by increasing production, that will result into more pollution. And so the company will need trade-off between profit and pollution. So if you look at this example, you can see that the company could produce at point A where it makes some profit and also some toxic waste. But at point B, we can see that this company will increase toxic waste at the same level of profit, which is not desirable. However, at point C, we can see that the company is increasing some profit, and the toxic waste will remain the same. And so point C is desirable decision, and also point A. So as I have said, in this case, we may have more than one objective functions, and so problem is one of the examples of the multiple objective linear programming models. So this problem says ABC Mining Company operates two different coal mines in Center A and Center B. Due to increased commercial and residential development in the primary areas served by these mines, ABC is anticipating an increase in demand for coal in the coming year. Specifically, her projections indicate a 48-ton increase in the demand for high-grade coal, a 28-ton increase in the demand for medium-grade coal, and a 100-ton increase in the demand for low-grade coal. To handle this increase in demand, ABC must schedule extra shifts of workers at the mines. It costs $40,000 per month to run an extra shift of workers at Center A mine and $32,000 per month at Center B mine. Only one additional shift can be scheduled each month at each mine. The amount of coal that can be produced in a month's time at each mine by a shift of workers is summarized in the following table. So we have seen that kind of information about the number of tons that is anticipated or is projected. And in order for the company to achieve this, then they have to schedule extra shifts of workers at the mines. And we can see we have mine A and B. And so we can see that there is an increase in the cost. If the company will have extra shifts, the cost to run an extra shift will increase, because here we can see if an extra shift is added, then it will cost the company $40,000 for mine A and $32,000 for Center B. And so here we have another information. We're looking at the types of coal. We have high grade, medium grade, and low grade. And we can get all this from the two centers. So Center A, that is 12 tons for high grade, 4 tons for medium grade, and 10 tons for low grade. In Center B, we have 4 tons for both high grade and medium grade, and 20 tons for low grade. Unfortunately, the methods used to extract coal from these mines produce toxic water that enters the local groundwater aquifers. At Center A mine, approximately 800 gallons of toxic water per month will be generated by running an extra shift, whereas the mine in Center B will generate about 1,250 gallons of toxic water. Although these amounts are within EPA guidelines, ABC is concerned about the environment and it doesn't want to increase any more pollution than is necessary. Additionally, although the company follows all OSHA safety guidelines, company records indicate that approximately 0.2 life-threatening accidents occur per shift each month at Center A mine, whereas 0.45 accidents occur per shift each month at Center B mine. ABC knows that mining is a hazardous occupation, but she cares about the health and welfare of the workers, and they want to keep the number of life-threatening accidents to a minimum. So we can approach this problem by developing a model. So we're going to start with the model, and we will follow same steps that we have been following for this kind of problems. And so the first thing to do is to define the decisions variables. It is very important to understand what decision variables we can use for this case. Now, if you look at this example, we can see that ABC has to determine the number of months to schedule an extra shift at each of the company's mines. And so we have this information here that says the company can run extra shift or one additional shift a month. And so we have Center A and Center B. And so our decision or the decisions will be between these two mines. And so we can define the decision variables as X1 to show the number of months to schedule an extra shift at Center A, and X2 to be the number of months to schedule an extra shift at Center B mine. So in this case, we have X1, as I have said, and also we have X2. So for X1 is number of months to schedule an extra shift at Center A. And so we can copy this and also can paste here, and that is Center B mine. So the next step is to define objectives. So here, and in this case, we will look at the number of objectives that the company can make. So from this question, we can see a number of objectives. So first objective here is to minimize the cost of adding an extra shift, where we saw that it costs $40,000 per month to run extra shift for workers at Center A mine and $32,000 for Center B mine. So that is our first objective. Here it shows that the company would like to reduce the amount of toxic water, where at this moment it is producing 800 gallons of toxic water per month at Center A and 1,250 gallons for Center B. So that's the second objective, to minimize the production of this toxic water. And the third one is the life-threatening the company is planning to reduce or to minimize the life-threatening accidents. And we can see we have 0.2 for Center A and 0.45 accidents per month for Center B mine. So we can add this in Excel as follows. So we're going to minimize 40, and I'm going to just take 40,000. So write 40 x1 plus 32 x2, and that is the production cost in 1000. And then we have to minimize 800 plus, and so this is the toxic water produced in gallons. And then we have to minimize the life-threatening accidents. So in this case, ABC company is forced to decide which of these three objectives is most important or most appropriate and use the single objective in the model. Next, we are going to define constraints. So we have constraints in this table. We have high grade coal required, and medium grade coal required, and also low grade coal required. And we can see in Center A we have 12 tons, 4 tons, and 10 tons. And Center B we have 4 tons, 4 tons, and 20 tons. Therefore, we're going to write them. So we have 12x1 and 4x2, and this should be because this is the amount of tons required, they should be greater or equal to the anticipated amount, which is 48, and that's for the high grade. And then we have 4 tons and 4 tons, so 4x1 and this should be greater or equal to 28. That information is provided here. 48 and 28, and that is the medium. But also we have 100, but it is 10 tons for A and 20 tons for B. And so that is one set of constraints. And then we have the non-negativity condition, which is x1 and x2 must be greater or equal to 0. Since we are able to define these sets of objectives and also our constraints, then we can organize this information in Excel and be able to solve to find the optimal solution. Next, we are going to organize this information in Excel and be able to use the formulas to solve, to do some solutions. And so here we have ABC company, and this company has some months to operate. And this months to operate, it should be in 2 centers. We have in Center A mine, and also we have Center B mine. So in this case, we let me copy this. And so the months to operate in Center A, we have no idea. So in this case, we can start with zeros, meaning that we're not doing any operations. And that will be our variable, those will be our variable cells. And then we can look at the objectives. And if you, what we did before, we look at the cost per month. That's the cost of adding a shift per month. And then we have toxic per month, and then we have accidents per month. Those are the three objectives that we need to reduce the cost per month, to reduce the toxic water per month, and also to reduce the accidents per month. And for center A, we know that we have $40 and $32. And for toxic per month, we have 800, and also we have 1250 gallons. And the number of accidents, we have 0.2 and 0.45. And so here we will look at the total, and these totals will be our set objective. And so we'll work on this later. Let's go down here. We need constraints, and so the constraints is we have them here. We have high, and then we have medium, and then we have low. And so for high we have 12, 4, 4, 4, 10, and 20. And so for here we have 12 and 4, 4 and 4, and then we have 10 and 20. And so if these are the constraints, then we are going to look at the availability, the available amount, and also we will look at the required amount. And you can see that the required amounts are 48, 28, and 100. So we have 48, 28, and 100. And so those are our constraint cells. These are constraint cells. So now we are going to see to apply the formulas. And so for the set cell, we're going to use some product of the cost per month, and that will be times the months to operate. So let me put equal sign there, and then some product. So you will select the cost per month times the months to operate. So you put the comma sign and highlight this, and then close the bracket, and then you can enter. So we could do the same for all this toxic per month and accidents per month, and this will refer to the months to operate. And so we will put the dollar sign to lock these two cells. If you're using Windows, you can press F4. You put your mouse here and press F4, and that will put the dollar sign. But if you're using Mac, there is a way you can do this, but also you can just put the dollar sign in between, and then you can see that we have locked this, and so you can enter. And in this case, you can copy the formula. So now we will need the formula for availability, and in this case the formula will be the same as what we have here, meaning that the availability will be the high cost, the sum product of the high times the months to operate, medium times the months to operate, and low times the months to operate. So in fact, I can copy the formula and apply it here, and then I can actually drag it down. So that will be okay. So the problem we have is we have more than one objective function. We have the cost per month, toxic per month, and accident per month, and we want to minimize all this. So we cannot have a single decision or optimal solution when we have more than one objective. And so to solve this kind of a problem, then we should first of all deal with one after another. And in this case, we will need to establish the target. What is the target of this company to reduce the cost per month? And what is the target for this company to reduce the toxic per month? And what is the target for this company to reduce accidents per month? So if you can remember the problem that we had on goal linear programming, we were given the targets. I can remember we were given the target for the small, medium, and large conference rooms. And so the small conference room, the target was to get 5, and also the target was to get 10 medium conference room, and the target was to get 15 large conference rooms. So in this case, we would like also to use the target. That will help us to know, that will help us to solve this problem. However, we are not given the target. So, but we can minimize the first objective, which is the production cost or the cost per month, and the optimal value will be our target. And then we'll minimize the second, and the optimal value will be the target, and that will be the same for the third. We will minimize accidents, and the optimal value for that will be the target. So with that being said, we are going to use solver to find the optimal value, which will, or values, which will be our target values. And but before we do that, let me put some the limits in this place. So uh, the limits here are that this will be greater or equal to the value, and that's what we have um, in the constraints. And so I'll copy this down here, but I'm going to add one more constraint, which is non-negativity constraints, and that will be for x1 and x2, that they will all be greater or equal to 0. And so the value for x1 will be the months to operate. And so I will click, I'll put the equal sign and click months to operate and enter. And also here I'll put the equal sign and click the months to operate for center B, mine, and then enter. So in that case, we are done with the limits. And so now we can use solver to find the optimal value and values, and we're going to start with the optimal value for the cost per month, and that will give us the target for the first objective, and then we'll find for the second and the third. So let's start with the cost per month. And so I'm going to click on the data and click on the solver. And in this case, I will select one objective or set cell, which is the cost per month. So I will select this one, and in this case, we are minimizing cost, and we're going to change some variables, and in fact, we will change the variables, the changing variable cells, which are this, and then we're going to add constraints. And in this case, you can see our limits are all greater or equal to the values. And so I will select all this and change the limits to greater or equal to their corresponding values. And so in this case, we are done. And so I can click OK. And we are going to use simplex method or simplex linear programming method. And then we can solve. So we can see that my solution is okay because all constraints and optimality conditions are satisfied. So I'm going to click OK. So here we have optimal solution, and we can see that the best possible minimum production cost for the problem is $244 in thousands. And so this can be obtained by running an extra shift at center A mine for 2.5 months and center B mine for 4.5 months. And therefore, the reasonable value for the target in terms of the cost of production per month will be 244. So let me copy these outcomes and I'll paste them just like values. And so let me write optimal solutions. And so this is our first optimal solution. And so the target or the target for the cost per month will be this one, which is $244. Meaning it is not possible to obtain a solution to the problem with production cost lower than this amount. So let's look at the trade-off for this target. For this optimal solution. We can see that the company will spend $244 as cost per month, and it will produce the toxic per month, which is 7,625 gallons, and the number of accidents per month will be 2.525. So the next thing is to find the optimal solution for the toxic per month. We will use solver, and in this case, instead of having the cost per month as our set objective, we're going to select the toxic per month as our set objective. And so we'll select on the toxic per month, and everything remains the same. That is, the changing variables will be the most demands to operate, and also the constraints will be the same, and we will still use the simplex linear programming model, and so we can solve. So we can see in this case that the best possible minimum toxic toxic water per gallons per month will be 6,950. And this can be obtained by running an extra shift at center A mine for 4 months and also for 3 months for center B. And therefore, the reasonable value for target or the target value for the toxic per month is 6,950. So I will copy this as well. Let me click this OK. And I will copy this outcome and I will paste. And that will be outcome number 2. And we have the target value for this second objective is this amount. Next, we're going to find optimal value, which will be the target for accidents per month. And since we have copied this outcome here, we can use solver and minimize the accidents per month. However, you can see the trade-off here when we find the optimal value for toxic per month. And here you can see that the trade-off is that accidents per month will be 2.15, and that's different from, will be a little bit less than 2.525 for the optimal value of the cost per month. And you can see cost per month in this case is 256 instead of 244. And also you can see that we have minimized the toxic water. So minimizing toxic water to this level means that it is not possible to obtain a solution to the problem with than this amount. This is the minimum amount the company can produce, but that will come with high cost of production, but also it will lower the number of accidents. So let's try to apply solver for to get the target value for accident and see what will be the results. And so in this case, the set objective will change and it will be the accidents per month. And everything will remain the same, and so we can solve. And so I'm going to click OK. And you can see that when we reduce the number of accidents, and the minimum that we can reduce will be 2 in total. And in this case, that will come up with more toxic water. That will be 8,000. And also the cost per month will be high, which will be 400. So the target here, let me copy this. So the target in this case will be 2. That's target number 3. So you can see that the outcomes that we had when we tried to minimize each one of the 3, there is no single feasible point that simultaneously optimizes all of the objective function. When we try to minimize accident, then we minimize accident to 2, but that increased the cost and also the toxic water. And so here as well, we can see that when we minimize cost, the toxic water increased, and also the number of accidents were at this level. So we can say that there is no single feasible point simultaneously optimize all of the objective function, and therefore we will need to, so we cannot use one of these to say that that is the best optimal solution. However, since we have developed the targets, now the next thing that we are going to do is to create the goals. And so remember what we did in goal programming, and so we're going to do the same. And in this case, we are going to define the goal. Objective. So the goal objective here, we are going to have goal number 1, and then we have goal number 2. Sorry. So we have those three goals. And in this case, the first goal is the total production cost should be approximately $244. And the second goal, it is that the gallons of toxic water produced should be approximately 6,950. And finally, goal number 3 is the number of life-threatening accidents should be approximately 2. We know that the actual total production cost, the toxic water, and accidents per month can never be smaller than their target values, which are $244, $244, 6,950 gallons, and the 2, which is life threatening. And therefore, the percentage value can be computed as follows. So here we have the percentage value. So the percentage value can be computed as the actual value minus target value. All this divided by the target value. So that's the formula we can use. And if we want to find for the total production cost, then that will be 40x1 plus 32x2, and that will be in bracket divided by minus 244 divided by 244. That is for the cost of production. I mean the cost of adding one more shift. And let's see, for the toxic, we have 800 x1 plus x2, and this will be into bracket minus 6950 divided by 6950, and that is for the toxic. And finally, we have for live threads. So we have 0.2 x1 plus it was 0.45, 0.45 x2 minus 2 divided by 2. And so that is for threats, the life-threatening accidents. So we will provide weights to all this, and therefore here we'll put weight 1, and that will be for this, and then we're going to apply weight for the second one, that will be weight 2, and then we'll close the brackets, and then we will apply weight to the third one, that will be weight number 3, and then we'll close brackets. And so all we're going to do in this case is to find mean, max, objective, and min-max objective explore the points on the edge of the feasible region in addition to the corner points. So we will minimize the maximum weighted percentage deviation from the target values for the goals in our example. So we implement this objective by establishing a minimax variable q right here. That we minimize with the objective min q. So minimize q subject to let me copy this. And this should be less or equal to q. And this one also should be less or equal to q. And this also should be less or equal to q. So the weighted percentage deviation from the target production cost and toxic water and accidents must be less than q. Let me copy these constraints, actually all these constraints, so we can implement the model. So these are 3 sets of constraints that we can use when we implement the model. But we have one more constraint, which will be the weight. So W1, W2, and W3 must be positive constraints. So they should be positive. They should be positive constraints. So we're going to end up here, but our next video will be the implementation of the model. Thank you.